In this video, we're going to look at rearranging equations and formulae. Let's start off with a formula that we've seen in the past. The area of a circle can be written as A is equal to pi r squared. So the area is pi, which is just a number, multiplied by the radius squared. Currently, A is the subject of this formula. We might want to make r the subject of this formula. If we wanted to do that, all we'd need to do is work this backwards. So if we consider how this started off, we took the radius and squared it and multiplied it by pi. Therefore, if I want to express r in terms of A, or make r the subject of this formula, I would do the inverse operations. So what we're going to first do is divide both sides by pi. So A over pi will be equal to r squared. The reason I've done that is that we've got r squared multiplied by pi. On the left hand side, I want now terms that exclude r, and on the right hand side, I only want terms that include r. Now at this stage, I want r. I've got r squared, so I need to do the inverse. The inverse is square rooting, so I'm going to square root both sides. Now technically, we get a plus or minus answer when we square root, but as we know, the radius is a length, so that will always be positive. So we can say now that the radius is going to be the positive square root of the area over pi. And we've made r the subject. It doesn't matter that r is on the right hand side and then the square root of a over pi is on the left hand side. We've made r the subject. This is very similar to solving equations. So if we had an equation 2x minus 1 is equal to 7. To solve this, we would now use inverse operations. We would add 1 to both sides. So we'd have 2x is going to be equal to 8. We would then divide both sides by 2. So 8 divided by 2 is going to give me 4. So I'm working this backwards. If we had another equation, let's say we had 2x squared minus 1 is equal to 71. We would now add 1 to both sides. So we'd have 2x squared is equal to 72. We would divide both sides by 2. X squared is 36. Then we would take the square root. So x is equal to plus or minus the square root of 36, and we could see that x is equal to plus or minus 6. So all I've done here is solved an equation. Over here I've rearranged a formula using the same technique. Let's have a look at another one. If we use the cosine rule, a squared is equal to b squared plus c squared minus 2bc cos a. So when we're finding a missing length or angle in a non-right angle triangle, this is one of the formulae that we can use. Now, I might want to make cos a or just a the subject of this formula. Currently, a squared is the subject. So what I'm going to do is go ahead and make cos a the subject. So I can see that I've got minus 2bc cos a. I'm going to add that to both sides. That's going to give me 2bc cos a plus a squared is equal to b squared plus c squared. On the left hand side, I only want terms that include cos a. Therefore, I'm going to subtract a squared from both sides. So 2bc cos a will be equal to b squared plus c squared minus a squared. All I want now is cos a. Cos a is multiplied by 2bc, so I'm just going to divide both sides by 2bc. So we've got b squared plus c squared minus a squared all over now 2bc. So all I've done is use the order of operations, and I've reversed this such that I've expressed cos a in terms of b, c and a, or a, b and c. And then if I wanted the angle a at this stage, we would just take the inverse cosine of both sides. We're not asked to do that, we're just simply rearranging the formula to make cos a the subject. So that's a brief introduction now to rearranging formula. What we're going to do is work through a few different examples and look at the techniques that we're going to use. Ultimately though, you're just using the order of operations and inverse operations to make a given letter the subject of the formula. So let's start off. We're asked to make x the subject of each of the following formulae. So y is equal to 4x. y is got to now 4, or y is equal to 4x. We've multiplied by x by 4. So if we wanted to undo that, we would need to divide both sides by 4. So y over 4 would be equal to x. X is now the subject. You could say now 1/4 y is equal to x. If we look at the next one, I want to make x a subject, so I'm going to subtract 3 from both sides. Y minus 3 is equal to 2x. I just want x, so I'm going to divide both sides by 2. And that gives me y minus 3 over 2 is x. We can see that x was multiplied by 2 and added 3, so I've done the inverse. I've subtracted 3 and divided by 2. This one, I would add 8 and divide by 4. Okay, let's look at this one. Y is equal to x plus 2 over 4. So we've got x in the numerator. I need to multiply both sides of this formula by the denominator of the fraction. So we'd have 4y is equal to x plus 2. And then all I need to do is subtract the 2 from both sides. So 4y minus 2 is equal to x. If we think about x started off, we added 2 and we divided by 4. So I've done the inverse. I've multiplied by 4 and subtracted 2. Okay, let's go for this one right here. We want to make x the subject. So I need to multiply both sides by c. So cy, or yc, will be equal to x minus a plus b. I want x only on the right hand side. So I'm first going to add a. So cy plus a is equal to x plus b. Then I'm simply going to subtract the b from both sides. So cy plus a minus b is equal to x. And we've rearranged the formula to make x the subject. Okay, let's move on and look at some more. So those ones are fairly straightforward. We're asked to rearrange each of the following formulae so that x is the subject. Okay, let's take this one. So x here now is minus 7x. My first move is to multiply both sides by 2. 2y is equal to 8 minus 7x. I can do this two different ways. The first way is to add 7x to both sides. So 7x plus 2y is equal to 8. I'm now going to subtract 2y from both sides. All I want on the left hand side are terms with an x in. So that's going to leave me 8 minus 2y. And at this stage I divide both sides by 7. 8 minus 2y over 7. And that now gives us x. At this stage, I could have done something different. What I could have done is subtracted, and I'll just write this out, 2y is equal to 8 minus 7x. I could have subtracted 8 from both sides. 2y minus 8 is equal to minus 7x, and then divided both sides by minus 7. We end up now with 2y minus 8 over minus 7 is equal to x, and these two are equivalent. If you are unsure, if you let y be equal to 2 and sub those in, you would get the same numeric value for x. So if we look at that, that's going to be 8 minus, and then we're going to have 2 lots of 2, which is 4 over 7. So that's going to give us now 4 over 7. If we sub it in here, we're going to have now 4, which is going to be the 2 lots of the 2, which is going to be now the 4. Then we're going to have minus 8 over now minus 7, which gives us minus 4 over minus 7, which of course is going to give us 4 over 7. So we can see either way round, we get the same value. Okay, let's look at some others. So they still are fairly straightforward, we're just using the order of operations. Okay, for each of the following formula below, make a the subject. So we can see on this one, q is equal to the square root of a over 4. So a started its life off, it got divided by 4 and then square rooted. So what I'm going to do is the inverse. I'm going to square both sides. That's going to give me q squared. The square of the square root of a over 4 is just a over 4. All we're doing now is doing the inverse operation or reversing this process. So q squared is equal to a over 4. I want a, so I'm going to multiply both sides now by 4. So 4q squared, which I need to be careful saying, is equal to a. You could at that stage actually say I'm going to divide both sides by 1/4. Dividing by 1/4 is the same as multiplying by 4. So all we've done are 2 steps. We squared both sides and then multiplied both sides by 4. So a is now the subject. This one right here, I could either say I'm going to divide both sides by 1/4 or multiply both sides by 4. So if I multiply both sides by 4, we get 4v is equal to the square root of a over 2b. A is still stuck under the root, so I'm going to square both sides. That's going to give me 16v squared. 4 squared is 16, v squared is v squared, and that's going to give me a over 2b. At this stage now, I want to make a the subject, so I'm going to multiply both sides now by 2b. So all I'm going to have then is for 2b multiplied by the 16v squared is equal to a. I can tidy this up, 32, and we can either write v squared b or alphabetically bv squared, and that's equal to a. So all I've done is simply now reverse the process. Let's look at this one. C is equal to 3 lots of the square root of 2 over b plus a, and we want to make a the subject. I'm going to divide both sides by 3. C over 3 is equal to the square root of 2 over b plus a. I'm now going to square both sides. C squared over 9 is equal to 2 over b plus a. At this stage, I can use a trick. I can go ahead and cross multiply, or I can use the following trick. I can write now, because I want to make a the subject, 9 over c squared is equal to b plus a over 2. All I've done is inverted both fractions. If you want to hit pause and think how that's done, please go ahead and do so. What I'm going to do shortly is show how I've done it the long way around. At this stage, I still want to make a the subject. I've got now b plus a over 2, so I'm going to multiply both sides by the 2. That's going to give me 18 over c squared is equal to b plus a, and I'm simply going to subtract b from both sides. So 18 over c squared minus b will be equal to a, and a is the subject of the formula. You could go ahead and combine those fractions. We're not asked to, but you could do if you wanted. Now at this stage, when I just went ahead and turned it over, what I'm going to do is show what I did. If I multiply both sides by b plus a and multiply both sides by 9, what we've done is cleared the fractions. So at this stage, I can see that I've got c squared multiplied by b plus a. So all I've done is multiply both sides by b plus a and both sides by 9, and that's cleared the fraction. So I've got now c squared b plus a is equal to 18. Dividing both sides by c squared, b plus a is equal to 18 over c squared, and then at that stage I'm just simply subtracting b from both sides. So a is equal to 18 over c squared minus b. So all we've done here is essentially now cross multiplied. I've multiplied both sides by b plus a, both sides by 9. It leaves us with that, clearing the fractions, and then we simply rearrange. Okay, let's look at some others. So those ones are still fairly straightforward. This time we're asked to make x the subject of each of the following formulae. So in these cases we've got x on both sides. Now this one is fairly straightforward. All we would do is subtract 1x from both sides to begin with. So if I do that, subtracting 1x from both sides, I have x plus a is equal to minus b. All I'm going to do is subtract a from both sides, so x is equal to minus a minus b, or we could write x is equal to minus a plus b. So either of those, perfectly fine, we've just worked that backwards. Let's look at this one here. I've got now x in both of the brackets. What I need to do is multiply these out and then collect like terms. So 4x minus 4a is equal to 3a minus 3x. I want x's on one side, and then on the right hand side I want terms now that are independent of x. So what we're going to do is add 3x to both sides. So 7x minus 4a is going to be equal to 3a. I'm now going to add 4a to both sides, so 7x will be equal to 7a. Dividing both sides by the 7, x will be equal to a. And all we've done is rearranged. So I've got now 4x minus 4a is equal to 3a minus 3x, and we've made x the subject and then just gone ahead and rearranged. Okay, let's look at another one. Let's look at this one right here. What I'm going to do is cross multiply. So at this stage I'm going to multiply both sides by 3, and that will give me 3 lots now of x minus a, and then multiply both sides now by 2. So I'm just cross multiplying. So we have now 3 lots of the quantity x minus a is equal to 2 lots of the quantity x plus b. Expanding out, 3x minus 3a is equal to 2x plus 2b. I'm going to subtract 2x from both sides, which leaves me x minus 3a is equal to 2b. And at this stage, I'm simply going to add the 3a to both sides. So x is going to be equal to 3a plus 2b. So again, all I've done is work that backwards using inverse operations. Okay, let's do another one. Let's just do this one. I'm going to multiply both sides by 5. That leaves me now 2x minus a is equal to 5 lots of x plus 1. Expanding the bracket, 2x minus a is equal to 5x, and then we're going to have plus 5. I'm going to subtract 2x from both sides, so minus a will be equal to 3x plus 5. I'm now going to subtract 5 from both sides, so minus a minus 5 is equal to 3x, and then divide both sides now by 3. So we've got minus a minus 5 all over 3 is equal to x, or we could write now, factoring the minus out, minus x plus, minus the quantity a plus 5 now over 3 is equal to x. Either of those two things are perfectly fine. Okay, let's move on and look at some more. So those ones are slightly more challenging. These ones now, we're asked to make x the subject of each of the following formulae. We can see that x appears in the numerator and the denominator. What we need to do here is multiply by the denominator of the fraction and then factor. So let's go for this one first. What I want to do is make x a subject. So I'm going to multiply both sides by x plus 1. So we've got p multiplied by x plus 1 is equal to x. I now expand the bracket. That gives me px plus p is equal to x. I'm now going to subtract px from both sides. So p is equal to x minus px. The reason I'm doing this is that on the right hand side I want terms involving x only, or terms that have an x in, and then on the left hand side I want terms without an x. I'm now going to factor the right hand side x, then we'll have 1 minus p, and then I divide through by the content of the bracket. P over 1 minus p is equal to x, and I've made x the subject. Okay, let's have a go at another one. Let's do this one right here. So what we're going to do is multiply both sides by the denominator. Q, then we'll have x minus a will be equal to x plus b. Expanding the brackets, I want the x out. Qx minus qa is equal to x plus b. At this stage, I'm going to subtract x from both sides. Qx minus x minus qa is equal to b. I only want terms in x on the left hand side, so I'm going to add qa to both sides. Qx minus x is equal to qa plus b. I'm now going to factor the x out. X q minus 1 is equal to qa plus b, and then I'm going to divide through by the content of the bracket. X will be equal to qa plus b over q minus 1, and we've made x the subject. At this stage you might have said to yourself, well, why don't you subtract qx from both sides and then subtract b? You certainly can, and you'll get the same expression. So I've gone for from right to left, purely based on the fact that I'm going to end up with a positive quantity rather than lots of negatives, but you can go the other way. Okay, let's do another one. Let's do this one. This one looks quite challenging. So we're going to do k. The first thing I'm going to do is multiply both sides now by 3 minus x squared. That's going to have now left p, the quantity 3 minus x squared, is equal to 2 minus x squared. Expanding the brackets, we've got 3p minus px squared will be equal now to 2 minus x squared. At this stage, I'm going to add the px squared to both sides. So 3p will be 2, we'll have minus x squared plus px squared. I'm now going to subtract 2 from both sides, 3p minus 2, and just rewriting this, we're going to have px squared minus x squared. I'm going to factor out the x squared, so we've got 3p minus 2 is equal to x squared, and then we're going to have p minus 1. We divide through by the content of a bracket. 3p minus 2 over p minus 1 is equal to x squared. We want to make x the subject of the equation, so we need to take the square root of both sides. We're going to get plus or minus the square root of 3p minus 2 over p minus 1 is equal to x. So all we've done is multiply through by the denominator. We've then multiplied out, we've collected like terms, we've factored and then divided through by the content of a bracket and then simply taken the square root. Let's do this one here. So if we now multiply both sides by the denominator, g x squared plus y is equal to x squared minus y. Expanding the brackets, gx squared plus gy is equal to x squared minus y. At this stage now, I'm going to add y to both sides and I'm going to subtract gx squared. So I'm going to have gy plus y will be equal to x squared minus gx squared. Factoring out the x squared, and of course we could factor if we wanted over here, we could factor y out. We don't have to, but we could if we wanted. Gy plus y is equal to x squared 1 minus g. And then at this stage I'm going to divide through by the content of the bracket. We're going to have now, and I will factor this, we've got y, we've got g plus 1 divided by 1 minus g. That's going to be equal to x squared. So we square root both sides, so we're going to have now plus or minus the square root of y multiplied by g plus 1 divided by 1 minus g is equal to x. Just remember, a plus or minus you're always going to get. If we just think about the quadratic graph, y is equal to x squared. If we have now the value, let's go ahead and do now a quadratic graph. So here's our parabola. If we have this point here and this point here, they both give us a value. Let's say that value is 36. The square root of 36 is either minus 6 or positive 6. So when we take the square root, we have a plus or minus. So those ones are slightly more challenging. Okay, let's move on to a couple more and then we will finish off. So we're asked to make u the subject of each of the following formulae. So a is equal to 1 over u plus 1 half. The first thing I want to do is get 1 over u by itself. So I'm going to subtract half from both sides. So a minus 1 half is equal now to 1 over u. Now I've got 1 over u. At this stage we've got a couple of choices. What I could do is simply now combine this fraction. If I combine this fraction, I'm going to get 2a minus 1 over 2. So that's writing a common denominator, and that's going to be 1 over u. At this stage, I can simply invert the fraction. So I've got 2 over 2a minus 1 is equal to u over 1, which is just u. So that's one particular approach. You certainly don't have to do that, but that is one way that you could look at it. Combine the fraction and then invert the fraction. And we saw an example of how that worked before. So let's look at this one. We're going to add 2 to both sides. So b plus 2 is equal to 1 over u. So we could now write that 1 over b plus 2 is equal to u. Just consider that's 1 in the denominator. Alternatively, you can think I'm multiplying both sides by the u and dividing both sides by the b plus 2. Okay, let's look at a slightly more challenging one. Let's look at this one right here. So what I'm going to do is subtract now the 1/3 from both sides. So 1 over x minus 1 over 3 is equal to 2 over u. I'm now going to combine these fractions. So I'm going to have 3 minus x over the common denominator of 3x is going to be equal to 2 over u. At this stage now, I can invert the fractions. So we're going to have 3x over 3 minus x is equal to u over 2. And then I'm simply now going to multiply both sides by 2. That will give me 6x over 3 minus x is equal to u. So in these particular cases, we're combining fractions and then inverting the fraction. So let's have a go at this one right here. What I'm going to do is subtract now 2 over v from both sides. So we've got 1 over r minus 2 over v is going to be equal to 4 over u. I'm going to combine this fraction. Let's just make these look slightly different. We've got r and then we've got v. So what we're going to have is v minus 2r, and that's going to be over v multiplied by r, and that will give us now 4 over u. So all we're going to do is invert the fraction. So we have v multiplied by r over v minus 2r is going to be equal to u over 4, and then we simply multiply both sides by 4. So 4vr over v minus 2r is going to be equal now to u. And we've made u the subject of the equation. Now you can go ahead and cross multiply and look at the longer technique, but it's perfectly fine to simply invert the fraction from there. So there's some nice examples. These ones are slightly trickier as we see, but we simply now isolate the term 1 over u, and then we look to combine the fraction and invert. Let's move on and just finish off with something slightly different. Let's see what we've got here. So making u the subject, fairly straightforward. This one here, it says the formula t is equal to 2 pi multiplied by the square root of L over G gives the time for a pendulum to complete one full swing. In part A, we're asked to make G the subject of the formula, and in part B, we're asked to find G if L is 0.5 and T is 1.4. So we want to make G the subject. So what we have is G in the denominator. So the first thing I'm going to do is divide both sides by the 2 pi. So T over 2 pi is going to be equal now to the square root of L over G. I'm now going to square both sides. That will give me T squared over 4 pi squared is going to be equal to L over G. At this stage, we can invert the fractions. So we can say 4 pi squared over T squared is going to be equal to G over L. Multiplying both sides by L, we can say 4 pi squared L over T squared is equal to G. So all I've done is simply now divided both sides by 2 pi. We've squared both sides, we've inverted the fractions and gone from there. Now you might think to yourself, well, at this stage I don't want to invert the fractions. All you're going to do now at this stage then is multiply both sides by G. So you can say GT squared over 4 pi squared is equal to L. Multiply both sides, so GT squared is equal to 4, and then we're going to have pi squared L. And then what we're going to do now at this stage is simply divide by T squared. So G is going to be equal to 4 pi squared L divided by the T squared. And we can see we get exactly the same expression. I'm just using a slightly alternative method. Okay, we're asked to find G if L is equal to 0.5 and T is equal to 1.4. All we would simply do is go ahead and sub this in. So what we've got then is the find. We know that G is going to be equal now to 4, then we're going to have now pi squared multiplied now by L, which is going to be 0.5, and then we're going to have that now over T squared. Well, T squared is going to give me now 1.4 squared, and we can plug that in and find our value. 10.07. So what we have then is 10.07, and that's given now to 2 dp. So all I've done is rearrange the equation and subbed the values in. So there we go, a basic tutorial on rearranging equations and formulae. All you're doing is simply using the order of operations to carry out the inverse operation to make a different letter the subject.